So as we continue on now with section 9.3, okay, we're gonna learn how to graph logarithms, okay? We've graphed exponentials, right? We can do that pretty easy. We pick our -1, 0, and 1, and then go from there, right? Now remember, with logarithms, okay, logarithms are inverses of exponentials. We talked about that last time, right? Where you switch your x and y and stuff. I think we did. I didn't look over this to look over the video, but I think we did. So let's go through these boxes here just to review exponentials, and we'll talk about logarithms and go from there. Okay? So exponentials, again, so it goes to the point -1 and 1 over a, 0, 1, and 1 and a. It's called exponential base a. It has to be a positive number. The base has to be a positive number other than 1, and that means a there. Okay, a has to be positive. And it's exponential growth if a is bigger than 1. It's decay if a is between 0 and 1. The domain is all real numbers, and the range is from 0 to infinity and has a horizontal asymptote of 0. Okay? All that's from section 9.2. Now, for logarithmic functions then, notice the points that it goes through. Basically, what did we do there? Yeah, we just switched x and y, because exponentials and logarithms are inverses of each other. So to find a logarithm, take your exponential and flip x and y, and then you've got your logarithmic equation, okay? So now this is called log base a or logarithm base a. And again, the base has to be a positive number other than 1, because remember the base of the exponent is the base of the log. Okay, now what's our domain then? Look over the exponentials. Is 0 to infinity. Good, that's our domain. Wow. Let's try that one again. 0 to infinity. And then what's our range? Negative infinity to infinity. Good. Okay, so the domain of the exponentials, the range of the log. The range of the exponential is the domain of the log, and vice versa. Okay. Now, instead of a horizontal asymptote, now this one has a vertical asymptote of x equals 0. Good. Okay. And then, of course, you know the transformation rules. As we shift it around, you know, depending on how we shift it, that's going to change our asymptotes and our domain and stuff. Our range won't change. Our range will always be all real numbers, but our domain could change depending on if we shift our graph horizontally, and then our asymptote obviously will change that way as well. So let's start graphing, shall we? Woohoo. Okay, so the directions here, we want to graph y equals 3 to the x and y equals log base 3 of x. So notice our bases are the same. We want to label our 3 key points on each graph, and then it says name each graph or each function, okay? All right, so 3 to the x then. Let's do this without an xy table. So if I'm at -1, it's going to be 1 over a, and in this case a is 3, so it's 1 over 3. So -1 and 1 over 3, roughly right there. Okay, then what point do exponentials always go through? 0 and 1. And then I have 1 and 3. So there's our graph right there.
What are these called again?
Exponentials. Okay. All right, now we're going to do our logarithm on the same one. So since my base is the same, guess what I just do with my x and y values? I just switch them, right? So instead of -1 and 1/3, I'm at
Positive 1 and negative 1/3.
no. That's changing the signs.
Oh, you're right.
You change the point specifically.
Yeah,
So
1/3.
1/3 and -1. Good. So I'm about right here. And instead of 0 and 1, I'm at 1 and 0. And instead of 1 and 3, I'm at 3 and 1. Good. And there's my graph there. Okay. So notice those graphs are reflective about the y equals that red axis, and that axis is y equals x. Okay. And that's graphically how you can tell if two functions are inverses or not. Okay. Graph them both, and if they're symmetric about the y equals x axis, then they are inverses of each other. Okay. Pretty simple stuff there. Okay, so if we were to name each function then, what would the black one be named? Exponential base What is a in this point? 3. Good. Exponential base 3. And then what's the blue one named? Log base 3. Logarithm base 3. Yeah. Don't overthink it, people. It's pretty simple. All right. So see our nice bold underlined stuff. Okay. They're corresponding points because logs and exponentials at the same base are inverses of each other, which is what we just talked about. Okay. Now we don't always have to graph the exponential to get the logarithm, but you can. Okay. If you struggle with graphs of logarithms, just graph the exponential first and then switch x and y. Because you all get exponentials pretty well, I think. Would safe to say? You know how to shift it and all that stuff and flip it if you need to and everything. So if you're not sure, find your exponential points and then just switch x and y. And then you have your logarithm points, okay? All right, so let's do these now. So we're going to graph each function. We're going to label 3 key points. We're going to name each function and then state the domain and range and the equation of the asymptote. And I'm going to blow this up to do it, so hang on. Okay, so for log base 4 of x then, so let's practice our points. So if it were exponential base 4, we would go to -1 and 1/4, correct? But with logarithms now, we go to
Positive.
1/4 and -1. So we go right there. Okay, and again, instead of 0, 1, we go to 1 and 0. Now on exponential, I would have 1 and 4. So for logarithm, then I go to 4 and 1. Good. And there's my graph right there. Okay. All right. So if we were to name that,
Log base 4.
logarithm base 4. Okay. Domain and range and asymptote. So what's my domain here? 0 to infinity. What's my range? Yeah, all real numbers, right? That's going to keep heading on up forever. And asymptote. What kind and where? Horizontal or vertical? Vertical asymptote at x equals 0. Good.
Wait, can you write that all down?
Can you look at the graph and do it?
Well,
What's my domain?
your domain is 0?
From 0 to what?
0 to infinity.
Good, right? Because domain we look left to right. Okay, range we look bottom to top. So what's my range?
Negative infinity to positive infinity.
Yep, all real numbers. And then what's my asymptote?
0.
Yeah, it's a vertical asymptote right here
And those change when there's a number up front, right?
at x equals 0. Say that again.
Those change when there's a number in front of the.
A number in front? No, because all that number up front is going to do is just stretch my graph.
Okay, but.
Okay? When we start shifting it, when the number's behind. Right,
Okay.
right. Okay? And we'll show you that here, Emma. Right, in just a second here. So let's graph this next one and do all that stuff, and then we'll move on. Next, okay? All right, so instead of -1 and 1/10, we're at
10 negative
1/10 and -1. Okay, and instead of 0, 1, we're at 1 and 0. Instead of 1 and 10, we're at 10 and 1. So what does a bigger base do? Yeah, it flattens it out, right? Squishes that. The x gets bigger faster, or the y gets bigger slower, however you want to say that. Okay. All right. So now, we'll talk about this later as well. But log base 10 is what's called the common log. Okay, because that's because our number is base 10, our number system's on base 10. Okay. And that is base 10, so it's called the common log. So if you see the log of something and it doesn't have a base, it's assumed base 10. So if I have the log of x, that's log base 10 of x. If I have log of 15, that's log base 10 of 15 or whatever, okay? So again, 10 is the common log, all right? Okay, so we've plotted our points. We know how to get those. Okay, what's my domain? 0 to infinity. What's my range? All real numbers, and what's my asymptote? X equals 0, right? Vertical at x equals 0. You don't have to say it's vertical, because by saying x equals 0, that automatically tells you it's a vertical line.
So the name of the function is log base 10?
Yeah, Or just log, this one you can even name log of x. You don't have to say base 10. It's like saying 1x instead of x, right? You can just say log of x. Okay? So now, again, since logs and exponentials of the same base are inverses, we can use this to solve some pretty complicated looking problems. Okay? So we're going to take this first one, we're going to set equal to x. Okay? Now, in this form here, this log form, I really can't solve this, correct? But let's put this in exponential form. Plus, this will be a good review for you anyway. So it's 5 to the x, good, equals 5 to the second. Oh, so what does x equal? Yeah, x equals 2. Right? If 5 to the x equals 5 to the second, then x has to be 2, correct? So now let's look at this then. So if my base and my number are the same, what does it equal? It equals the exponent. So if I had log base 10 of 10 to the fourth, what would that equal? 4. If I had log base e of e to the 25th, what would that equal? 25. Right. Okay.
So the base and the number are the same, the exponent is.
That's what it's equal to. It's equal to the exponent. They cancel each other out, if you will. That's a really bad way of saying that because technically they don't. But yeah, if the base and the number taking the log of are the same, then it equals the exponent.
X equals the exponent, always.
Correct. That log equals the exponent. Okay. Now let's look at part B. So I have 7 raised to the log base 7 of 6. And we're going to set this, let's make this one y. Okay. Now, goofy as that looks, that's actually an exponential form. Okay, so let's put this in logarithm form. Okay, so I'm going to have log base, what's my base? 7 of y equals the exponent. What's the exponent?
7 to the 6.
Log base 7 of 6. So what does y equal here?
6.
Y equals 6. Good. So if I have a number, a base raised to an exponent, to a logarithmic exponent, and both bases are the same, so the exponential is base 7 and the log is base 7, it's simply equal to the number right there.
How'd you write the left side of the equal sign up there?
Log base 7 of y?
Yeah.
Okay, because that's in exponential form, correct?
Yeah.
Okay, so I have this base and this exponent, and I just said equal to y. Well, to put it in logarithm form, okay, I have log base 7 of y equals the exponent.
Okay.
Correct? So that's what I did. So since my exponent was log base 7 of 6, that's right here. And then if log base 7 of y equals log base 7 of 6, then y, like you said, y has to equal 6. Okay? Does that make more sense? Okay. All right, now let's put these in general terms. So if I have log base a of a to the x, what does that equal? Just equals x, right? That's all we got to do. Okay, so now if I have a raised to the log base a of x, what does that equal? Just x. That just equals x, right? Just like we showed on part B here, just equaled 6 on part D. So those are two logarithmic properties that you're going to need to know. Part C and part D right there. Okay. All right, so now let's apply these properties. Okay, so part A, if I have log base b of b, what's that equal to?
1.
Good, Emma, just equal to 1, right? The exponent in this case would be 1. Okay, what if I have log base b of 1? B to what power? Anything to what power is 1? No.
0.
Yeah, 0, right? Anything, remember we talked about this last time. If this number right here is 1, that always equals 0, because anything to the b to the 0 power is 1 is what we're saying. And is that correct? Is b to the 0 power 1, whatever we decide to make b? Yeah, anything to the 0 power equals 1. So whenever you get a 1 right there, the answer is always 0. Okay? All right, what about log base b of 0? Nope, it's not 0. So in other words, b to what power is 0?
Negative.
b to the b power is definitely not 0.
Negative.
Kind of a trick question. Think of your domain of logarithms. What's your domain of logarithms?
Can't be 0.
From 0 to infinity, and is 0 included? It is not. So can it ever be 0?
No.
It cannot. This is undefined. Now, using that same logic, look at part D. So 8 to what power is negative 8?
Undefined.
Correct. Okay, some people might say negative 1, but what's 8 to the negative 1 power?
8.
Not 8, that's 8 to the first power. What's 8 to the negative first? Negative 1 power. Yeah, you can do that. You can do 8 to the negative 1. That's 1 over 8, correct?
Oh.
Right? 8 to the negative 1 equals 1 over 8 to the positive 1. Right? But that being said, 8 to the negative 8, undefined. Negative numbers are not part of our domain for logarithms. Okay, so now we kind of have the basic idea of how logs work. Now we can solve some problems that look kind of evil in exponential form by just putting them in logarithm form. Okay? But you got to remember a few things. All right, these 4 things, commit them to memory, please. Logarithms are just another way to write exponentials. Good. The answer to a logarithm is an, right? Log base whatever equals the number. Yeah, it's always the exponent. Logs are equal to exponents, okay? If you're having trouble in exponential form, write it in log form. Good. And if you're having trouble in logarithmic form, write it in exponential form. Good. Remember that. Okay, let's practice a little bit, shall we? So part A. So log base 6 of x equals 2. Okay, little trouble here, so let's put it in exponential form. So what's exponential form there? 6 to the second power equals x. Oh, what's 6 squared? 36. We're done. Okay. Let's look at part B. X, okay, log base x of 8 equals 1/2. Okay, again, put it in exponential form. Okay, what's exponential form here?
So
X to the
1/2.
1/2 equals, x to the 1/2 equals 8. Correct?
Did you say x to the negative 2?
Leave it as 1/2. A little easier to work with that way. But yes, you could do that, Josh. Okay? So how do we get rid of a 1/2 power?
Multiplied by.
Yeah, by its reciprocal. The reciprocal of 1/2 is 2. So we're going to basically raise both sides to the second power. It cancels out here, and we get x, and 8 squared is 64. So in other words, 64 to the 1/2 power equals 8, right? Because 1/2 power is the square root, so the square root of 64 is 8. Okay, part C. Log base 3 of 81 equals x. Again, try exponential form.
3 to the x equals.
So 3 to the x equals 81. Can I write 81 as a base of 3?
Yes.
Everybody say yes.
It's 27.
That's not everybody. Everybody say yes.
Yes.
Thank you. Okay, so let's think about 3, okay? So what does 81 break down into?
27.
Not 27, 3 or 9 and 9. And what do 9s break down into? So I got 3 and 3 and 3 and 3, right? So 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So 81 is 3 to the fourth power, right? Right here, Josh, 4th power. So what does x equal? X equals 4. Good. Last one and we're done. Okay, now this looks a little screwy, but again, let's try exponential form now and see what we can do with it. So what's exponential form here? 32 to the 2/5 equals x. Okay, now we got to figure out 32 to the 2/5. Well, let's put this in radical form. So this is the what root? 5th root of 32 squared. What's the fifth root of 32?
2.
Yeah, think about it, right? 2, 4, 8, 16, 32. Boom, it is 2. So now we get 2 squared, which is 4. So x is 4. So log base 32 of 4 equals 2/5.
Are you going to say squared equals 4, or is it x equals 4?
It will, that would be both.
Okay. Well, I was trying to answer.
It's 4.
Just straight up, just 4 right there.
Don't complicate it, Josh. It's just 4, dude.